Designing a nail polish means creating a formula that will allow application to the fingernail of an even, brilliant film, whose plasticity and adherence will be optimal and which will have the most attractive color possible. Application, drying, glossiness and duration are the four primary qualities of any nail polish. Designing a nail polish means achieving a successful combination of components and finding the right balance between them to enable each to express its own particular characteristics. A nail polish is composed of polymers, among them nitrocellulose, the basic component that provides the thin, flexible film laid down on the nail. Auxiliary resins, these enhance the enamel's adherence, suppleness and gloss. Plasticizers, basically these make the film more flexible and also enhance its shine. Solvents and diluents, these stabilize viscosity and speed of drying. Solid pigments, the source of the color. Pearl to make the enamel more vivid and create a range of effects. And lastly, thixotropic agents to stabilize all these solids. For each individual nail polish, L'Oréal researchers endeavor to innovate and arrive at a formulation offering the best possible balance between four objectives. The fastest possible application in order to reduce drying time, a high gloss film, the best possible adherence for a longer lasting finish, and optimally attractive color. Constant improvement of the selection of base materials and manufacturing processes through a use of a battery of tests. The story of a nail polish begins with nothing more complicated than a glucose molecule. 100,000 or so of these molecules are bound together by oxygen to form a macromolecule of cellulose. This molecular structure will be transformed into nitrocellulose if just the right percentage of nitric acid is added. This is then dissolved in a solvent. Due to its very good mechanical and chemical strength, this film-forming agent offers the advantage of producing high-gloss films. Plasticizers are added to this mix. At the micromolecular level, you can think of these plasticizers as being a little like the springs in a mattress. They take up positions between the polymer chains and act as shock absorbers. Plasticizers stop the enamel from becoming brittle. The resins and plasticizers are added to the mix of solvents and nitrocellulose, forming what is called the glossy base of the enamel. When the gel is manufactured, there is a risk that the solvents used will give off vapor in the room, so to avoid generating sparks, all electrical systems here are explosion-proof. Here the suspending agent is being poured into the solvent, and the whole is then stirred energetically. After a few minutes, the result is a creamy gel. The enamel is therefore more viscous when left alone and more fluid when stirred, a characteristic known as thixotropy. The gel and the glossy base form a new mix known as a collodion. This has all the physical properties of the final enamel. And if we add to the collodion a pure pigment, what we get is a single color enamel. All that remains to be done is to produce a specific shade in the collodion. This is done here by combining two single color enamels and some glitter. And the next step is to test the product and measure its different characteristics.